I'm going to be talking about Java and blockchain. I wanted to start just by talking about what a blockchain actually is. So a blockchain is a decentralized, immutable data structure. It's decentralized in the respect that it's maintained by a number of nodes on a network. That network can be public or private, and those nodes don't necessarily have to trust or know one another. In terms of the actual data structure itself, it's basically a series of blocks linked together like a linked list, and within those blocks you have data which typically tends to be in the form of transactional data. So blockchain itself emerged in 2008 with the arrival of Bitcoin. Now Bitcoin, I'm sure many of you have heard about it. It was the first decentralized cryptocurrency to come out. So prior to Bitcoin, other cryptocurrencies had been proposed, but none of them had managed to solve the problem of how do you actually have a decentralized cryptocurrency where no individual or organization actually has ownership or ultimate control over this. So the big problem that Bitcoin solved was that area of trust and being able to transact with people that you didn't necessarily need to trust on the network. Now, the way in which Bitcoin works is that you have a Bitcoin address, and Bitcoins can be sent from one party to another by these addresses. Details of all of the Bitcoin transactions are stored on a transaction ledger. So much like your bank account has you've got transactions in terms of debits and credits associated with it, Bitcoin has a public transaction ledger which has details of every Bitcoin transaction that happens. You look at that, you can see Bitcoins going from one address to another address. That transaction ledger in Bitcoin is known as the Bitcoin blockchain, and that is where this whole area came from. In order to actually write entries on the Bitcoin blockchain, Bitcoin has a simple scripting language in order to do that. And because it was created for the purpose of creating transactions on this ledger, then it was a fairly primitive scripting language. And these issues with the Bitcoin transaction ledger for a young Canadian-Russian guy called Vitalik Buterin, who was one of the founders of the Bitcoin magazine, it was quite a big frustration to him, and he thought, well, what if we could actually take Bitcoin's blockchain technology, but also have a richer environment with it, one which was more like a computer where we could actually have a Turing-complete programming language that could run on it. So you've got things like your while loops and so on in it. The idea being that you could write any sort of traditional computer program and it could actually execute or reside on this blockchain technology. The name of that technology, which it came out with in 2013, was called Ethereum, and that was really the first significant inroad into blockchain in terms of the technology you hear so much about at the moment. Shortly after Ethereum, another technology came along named Ripple, which was focused on inter-organization payments. Then in 2014, things really started to pick up a bit in the space. So you had a consortium of what became about 75 of the world's largest banks put money in to form a company called R3, which was focused initially on finding applications of the blockchain technology, but then it sort of evolved into them creating their own blockchain technology called Corda. You've got Digital Asset Holdings as well, which is run with the CEO of the organization is someone called Bly Masters, and she was credited with creating the first credit default swap back when she was at JP Morgan. And then also is the San Francisco startup called Chain, who've got another blockchain technology, and then the Hyperledger project as well. The Hyperledger project is really an umbrella organization where all of the big Bitcoin players blockchain players have got involved in. It's actually a part of the Linux Foundation, and the idea is that it's an umbrella organization for blockchain related projects, and it's now actually being headed up by Brian Behlendorf, who's one of the original founders of the Apache HTTP server and also founder of the Apache Foundation. So you can kind of see the direction that the Hyperledger project's going. Then in 2015, things sort of went crazy in this space, and you ended up in a situation, this was as of December last year, just a survey of some of the blockchain-related startups just in the financial space, and so its application is wider than just finance. And almost a year later, you can imagine how much more this picture would have actually expanded. So I'm going to be talking a bit more about Ethereum today. The reason I'm talking about Ethereum is that it's really the original blockchain technology, and it's also the original blockchain in terms of being blockchain 2.0, which is what's being discussed these days in business and so on. Ethereum is a public blockchain technology, so like Bitcoin, the blockchain resides in the public domain. You have two types of blockchains typically, public and private. Private means it's run within an organization or intra-organization, but it's not publicly accessible, much like any intranet versus the internet. Whereas Ethereum's fully out there in the public. It's known as the world's computer because it works in a way like a computer, basically. You can write code and you can deploy it to this blockchain in the same way that with Bitcoin you could send a transaction to the Bitcoin network and this transaction would happen in a decentralized manner. What Ethereum enables you to do is to write code and have that code execute in a decentralized manner and actually get written to the Ethereum blockchain. It provides a Turing-complete virtual machine, so much like, for instance, with any interpreted language, Java being a great example, you compile your Java code down to Java bytecode. That bytecode gets executed by the Java virtual machine. In Ethereum, you have code that gets compiled down to what's called Ethereum Virtual Machine Bytecode, or EVM, and that then runs in this distributed computer that's completely decentralized. So it's quite a radically different way of doing things compared with, I guess, technology that's gone before in that regard. There's two blockchains with Ethereum. You've got testnet and mainnet, reflecting the test and the production environments respectively. Then you're probably thinking, okay, well that's all well and good. You've got this public computer, but how is it that you actually pay to use it and so on? And that's what the cryptocurrency Ether is all about. So Ether is the fuel of the Ethereum blockchain. In order to execute the code that you write and deploy to the Ethereum virtual machine, you need to pay for that. And so you pay for it using this cryptocurrency called Ether. Now, Ether is actually a standalone cryptocurrency in its own right. It's got a market capitalization of approximately $1 billion versus Bitcoin's 10 billion. And it's actually the second largest cryptocurrency after Bitcoin, so it's definitely one to keep pay attention to. Much like Bitcoin, holdings of Ether are associated with an address, so you can do all the same sort of things that you can do with Bitcoin in terms of transacting with other people with it, but then you also use it to run code. In order to obtain it, you've got a couple of options. The first is to buy it, so then either you need to find someone who will happily sell some to you, or you can go to an exchange in order to do this. So one of the big exchanges is called Kraken for doing this, but you've also got BTC markets here in Australia. And the other, probably more fun option, is to actually mine it. Now, in order to mine Ether, unlike Bitcoin, where you have to use this dedicated hardware that's specifically for mining it, with Ethereum you can actually do it using GPUs. So if you've got like a gaming PC or something like that with some ATI chipset graphics cards on it, you can actually start mining, but the power bills are pretty expensive for this stuff, and it takes a bit of time to generate if you want to generate real Ether. With the testnet environment, it's set up in such a way so that you can actually quite quickly generate Ether, literally, in an hour or so. You can have plenty there to play with, so it's a lot easier to get up and running there. So I spoke about the code side of things with Ethereum and how you can deploy code to the Ethereum network that then gets executed. This code and these programs that run within the Ethereum virtual machine are referred to as smart contracts typically. The idea being is that they run kind of like a computerized contract. So, as with any traditional contract, you've got clauses in it, much like with any program, you've got clauses in it. what you do is you push these contracts to the Ethereum network, and then they just sit there, and then as and when you call those contracts to invoke like a method on them, or a clause in the sense of a traditional contract, it can then cause some sort of state change to happen with the underlying contract. And ultimately, in terms of how they're represented on the blockchain, we saw earlier how the blockchain is an immutable data structure, and so you have code and data living on the blockchain. You can think of it much like a append-only log sort of data structure, whereby in order to actually update a smart contract, you don't actually modify what's gone before, because we've got an immutable data structure there you append to it. So again, like an append-only log, or with certain architecture such as event sourcing, where you only append events. That's sort of how things happen. In terms of the types of transactions, we've already spoken about how you can transfer Ether from one party to another. Then you can also deploy one of these smart contracts to the Ethereum network, and then you can invoke a method call or transact with an existing smart contract. So those are, broadly speaking, the three types of transaction that you're actually going to want to do with the Ethereum network. So to break it down a little bit more and actually see what's involved with transacting with the Ethereum network, on our left here, we've got our transaction object. I'm just going to run through some of the bits and pieces on here. So you have an address that ultimately you want the transaction to go to. You have some data associated with the transaction, which could be some EVM bytecodes, which you want to deploy to the Ethereum network. There could be some value associated with the contract. Then you've got what's called a nonce, which is a unique transaction identifier, so that when you send a transaction for the first time into the network, what it does is, the first thing that happens is that it checks that has that address sending the transaction actually used that nonce before? If so, it gets discarded, and likewise, if it's not the next expected nonce, it also gets discarded. But fundamentally, it's just a way of tracking transactions to ensure that you don't do the same transaction doesn't happen twice, solving this issue known as double spending. You also have two other details here called your gas price and your gas limit. Now, these are where you actually pay for the execution of the transaction. So your gas price is the price in Ether you're prepared to pay per opcode execution on the Ethereum virtual machine. And then the gas limit is the total amount of gas you're prepared to pay. So say, if you've got the gas limit, each individual opcode has got a set cost, and then you can tally up how much you think it should cost. But in order to ensure that you don't wipe yourself out completely by deploying some code there, you always want to ensure that the network enforces that you always have a limit in place that puts an upper boundary on how much a transaction can actually cost. So you've created your transaction. Then the next thing is that the transaction needs to be signed. So with this, it actually takes a private key that's out of your wallet file, and then it takes a hash of your transaction blob, and then using your classic asymmetric public private key cryptography, where you use your private key to sign the transaction, and then the public key can be used to verify that you actually signed the original message with your private key, and then that gets sent through to your Ethereum client. And then your Ethereum client is basically your gateway to the network, and then it'll do some fairly basic validation on everything to make sure, for instance, the transaction signature is valid and so on, and then it'll propagate it around the network. And then you've got two types of nodes on the actual network. You have regular clients, which are responsible for really just downloading the blockchain and being a gateway for sending transactions onto the network. And then you've got clients that are also miners as well, and what these miners do is they spend their time assembling all the new transactions that have gone into the Ethereum network and then forming new blocks to append to the Ethereum blockchain. So once this new block's been appended to the Ethereum blockchain, which has got a transaction with it, then at that point you can say that the transaction has completed, and then you're done basically. So in terms of the actual practicalities of integrating with Ethereum from an application perspective, these Ethereum clients, they expose an interface over JSON RPC, which is a JSON-based remote procedure call protocol, which is very straightforward, as you know, most JSON stuff is. And with those commands, you can do really basically anything that you need to do with the network, you can do over this JSON RPC API. However, it's not just a question of implementing this JSON RPC API. For instance, if you want to send a new transaction into the network, that transaction needs to be signed. So you need to have the ability to sign the actual transactions yourself before sending them through. Likewise, if you want to deploy a smart contract, these smart contracts need to be compiled, and then constructors and methods and so on need to be encoded in a specific format for them to actually be accepted by the Ethereum virtual machine. This is coupled with the fact, for instance, that the native types within Ethereum as well are 256-bit integers, unlike your classic 32 or 64-bit that you're used to working with in regular applications. So there's all these additional details that you need to take care of if you want to talk to the Ethereum blockchain. And these are the problems that Web3j set out to solve. So what Web3j is that it's a library that provides a full implementation of all of the JSON RPC protocols, so everything that you need to do in terms of interacting with a Ethereum client, you can do from just native Java code. It supports Ethereum wallets, so you can create new wallets, you can modify the passwords associated with your wallets. It can also generate Java code as well, so that you can interact with these smart contracts and code that's on the Ethereum blockchain from native Java code like it's just regular Java, so there's an entire layer that's taken care of for you. It also comes with command line tools as well, so that you don't have to hack together bits of the library and just run them out of your IDE or whatever in order to get that functionality. I've got a dedicated command line build as well of the library so that you can use that alternatively. And also, as of a couple of weeks ago too, there's an Android port of it as well, so it's you're good to go in, whether you're a Java or Android developer. In terms of the actual library, it's available on Bintray JFrog and then also Maven Nexus as well, just to make it super simple to pull it in. And then new releases of the command line tools are on the releases page of the project on GitHub. So if we refer back to a couple of slides ago where we had a transaction, we'll just run through the differences that when you're using Web3j it makes when actually transacting. So before we had our transaction object, and there were a whole load of details in here that I went through, but from the point of view of an application developer, you shouldn't really have to care about those. So Web3j takes all of that away from you, so all you need to think about is, okay, well, what's the operation I need to perform? Do I need to transfer Ether? Do I need to deploy a new smart contract? Do I need to call an existing smart contract? And then Web3j takes care of all of that. It takes care of the transaction signing for you as well. It also takes care of polling the status of the transaction too, because typically what happens is when you push a new transaction out to the Ethereum network, you won't get notified that the transaction's completed. You actually need to poll to find that out. So Web3j does all of that stuff for you. It provides By default, you'll get all of your responses in futures as well, so that so that you can work with this asynchronously. So when you actually want to get up and running with Ethereum and Web3j, the first thing you need is access to an Ethereum client. There's a service called Infura, which provides free Ethereum clients in the cloud. I think because of Ethereum's relative immaturity, this is a great service to have out there, whereby you just get an HTTP endpoint which is running an Ethereum client. The only challenge, though, is that you need Ether in the first place in order to transact, so you have a bit of a chicken and egg problem there. However, you can also run up an Ethereum client as well, and that'll enable you to generate Ether fairly quickly as long as you're using the testnet there. There's Ethereum clients written in all sorts of different languages. Now, in Bitcoin, you had a reference client implementation that was written in C++, and everything any other language implementations had to replicate the C++ reference implementation. So that meant if there were bugs in the C++ one, they had to be replicated, say, in your Java port and so on, just so everything was compatible. With Ethereum, there's a formal paper which specifies all of the semantics of how the network works, and so as a result, developers have been free to implement clients in whatever languages they want. The two main clients out there are called Geth and Parity. Geth's written in Go, Parity is written in Rust. There is a Java Ethereum client, but it's not as feature as complete as these two. So if you are going to run an Ethereum client, Geth's definitely the simplest one to run, followed by Parity. But Parity has been a bit more resilient anyway with some of the issues that have been seen in the public network in the last few months. So you've got your client running. You can then create a wallet. You can create wallets using the clients, but because we're talking about Web3j today, I'm going to talk about how to do it in Web3j, and also I believe it's simpler to do it using Web3j. So all you have to do is download the command line tools, and then you type wallet create, and then you enter your password, and then you get a wallet file generated in the location that you specify. The wallet file itself just contains your address at the very top there, which is your wallet address. So if you want to send funds to someone else, they'll show up as coming from that address. And likewise, if you want to receive funds, if you deploy a smart contract, it'll show as originating from that address. In terms of the ciphertext, that's basically your encrypted private key, which is used for all of the transaction signing, and then you've got different parameters there associated with the actual wallet file. Now, although the wallet files are password protected, you still don't want to share these wallet files because you have a number of the parameters that are used for actually generating the encrypted data, and so by keeping the wallet file under wraps as well as the password, it's like you've got two layers of protection there basically. In order to view transactions on the Ethereum network, you've got a service called Etherscan. Now, what Etherscan gives you is just really a nice web page for viewing events on the Ethereum blockchain. So here you can see where we've got an address here, and you can see the balance of Ether associated with it. This is testnet. Unfortunately, I don't have anything like this much Ether in the real network, but you kind of get the idea of how it all fits together. So we'll come back to that in a minute when we do some when we run some other transactions on the network. In terms of Web3j itself and looking at the actual Java code, I've tried to keep everything as simple as possible. I think that especially because the Ethereum and blockchains are very immature technology still, there's an awful lot of work that needs to be done to simplify it, and this was really the problem that I set out to solve in the first instance with the Web3j. So in terms of what you need to do in your Java code, once you've pulled in the library dependency, all you need to do is you need to build a new instance of this Web3j client, and then you can use that to actually interact with one of these Ethereum clients. The actual calls, they all follow this similar sort of setup where what you have is you call the Web3j library, and then you say what method name it is you want to invoke, and then you say whatever parameters you want to pass with it, and then you can send the actual message synchronously or asynchronously. It's up to you. But this is if you're talking the sort of raw JSON RPC stuff, which is the fairly bare bones stuff. Although, as I showed in the slide earlier on, Web3j kind of brings a lot of stuff together to simplify it, and behind the scenes that's using these send async calls. So here's a simple version of just a simple bit of code just to sort of show that your connection's working and all this sort of stuff. So you start by building a new Web3j client instance, then you call just to get the version of the client that's running, and then we print out what the client version is there. So here in this instance you can see it's running Geth, which is the Go client that I mentioned earlier. So this is basically the first thing you want to do just to check that everything's running as expected. To actually send some Ether, there's two ways of doing this. You can actually use the command line tool. So I've just got a command you can run, and you can use that to transact and send Ether to someone else on Ethereum. But if you want to do it in code, it's 3 lines of Java code to actually instantiate your Web3j your Web3j instance, and then you just need to load your wallet file, and then you can send Ether, and then it's done basically. So here we're sending 0.2 Ether to someone else. the actual native unit used in Ethereum is something called WEE, where one Ether is actually 10 to the power of 18 WEE. So in terms of the granularity there, it's pretty fine. And so in order to simplify things, you have different units of Ether that can be for transacting. So you've got Ether, but then you've got all these other ones. And again, Web3j takes care of that for you, so you can specify which unit specifically you want to transact in, and it does all the conversions behind the scenes. So then back to Etherscan, we can have a look at our transaction that we just did there on the actual live blockchain. And so we have at the top there a transaction hash, which is basically just a unique identifier for that transaction. And then when it's actually been mined, you'll get this nice display here where you can see all of the details associated with the transaction. So we have down there like who it actually went to, the value, which is 0.2 Ether, the actual amount of gas that we spent on it, and what gas price we paid for it, and how much was actually used by the transaction. Then we can also see as well the block on the blockchain that the transaction ended up into. Okay, so the smart contracts in Ethereum. They're usually written using a language called Solidity. I say usually because there are a couple of other contract languages that you can use, but Solidity is by far the dominant one. It's a high-level statically typed language. The semantics of it aren't that different to any high-level language. But in order to actually deploy these smart contract codes to the Ethereum blockchain, what you need to do is just compile it using the Solidity compiler. And then you can use Web3j to generate smart contract wrappers so that you don't need to worry about encoding and decoding the Solidity code into the right format, because it uses an intermediary format before it can actually communicate with the Ethereum clients. So here's some Solidity code. This is a simple example. What we have there, we've got at the top a base class called Mortal, and then we've got a child class of that called Greeter. The idea with Mortal here is that you've got an address at the top. That address is an instance variable associated with the Mortal contract, and then you have your constructor here, which basically says the owner, the instance variable owner is just the sender of the message, i.e. the person who creates the smart contract. You've got a function that kills the contract. Obviously with the Ethereum blockchain being immutable, it doesn't actually delete it. All it does is you'll get another record there basically being written saying that it's no longer a valid contract to interact with. Then in your child class here, you've got basically it's extending using the is keyword in order to extend the Mortal contract, and we just have a local instance variable there, which is just a string value, and then there's a constructor that takes a string value, and then you've got a getter method. So it's a very, 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 very basic smart contract. So with the smart contract, what we first of all need to do, you need to compile it using Solidity, the Solidity compiler, Sol-C. And then this generates two assets that you need. One of them is a binary file, which is just your Ethereum bytecode that represents the instructions that the Ethereum virtual machine needs to execute. And then you also have what's called an ABI file, which is a JSON file that's a specification of the interfaces, the public methods on the contract that you can actually call. Once you've got those, then you can use Web3j to actually generate a smart contract wrapper. And so you pass in this bin file and this ABI file, and then it generates a Java file for you. Now, it's complex in terms of there's a lot of stuff there on the screen when you actually look at what's inside these generated files. But as with a lot of code gen use cases, the point is the interface that you actually use for it. Typically, you shouldn't have to concern yourself with these details. But behind the scenes, because Solidity and Ethereum, it's got its own entire set of types around. It's got unsigned, signed integer values, but those values go from 8, 16, 24, 32, 40, 48 bits, and so on, all the way up to 256 bit. So there's an awful lot. You can't just do straight conversions from Java to straight conversions from Java types straight into Ethereum types. So Web3j does all of these type mappings for you and this is a lot of what you see here. So you can see that there's conversions happening. So there's really just three things to draw your attention to. The first one is the fact you've got the binary there, which is the compiled code of the contract. Then you've got a greet method, which what this is doing is basically will go out to the Ethereum blockchain and then call the greet method on a smart contract that's been deployed to the Ethereum blockchain. And then down the bottom, you've got your deploy method as well, which takes what was the constructor to your smart contract, and this will actually deploy it to the Ethereum blockchain for you. So then when you're actually working with it, this is all you actually need to do to run it. You create a new instance of the Web3j library and then pass in your credentials, and then this is the actual public API that you'll see for that contract. So you start by deploying the contract, pass in whatever value you want, and then you call your getter on it. And what that's done is it's deployed the contract to the Ethereum virtual machine. It's running this this decentralized computer, and then you've just called a getter method on it to get your hello world from the blockchain. So there's an awful lot that you can do with smart contracts. I'm not going to spend today going through detailed examples of those because there's plenty of examples already out there. I just wanted to give you a taste of what's actually possible with this stuff and how you can use Web3j to actually simplify all of this stuff, which is quite fiddly behind the scenes when you actually get into the nitty-gritty of it. But the classic use cases of smart contracts that a lot of people are very interested in is where you have an underlying asset and you've got a contract that tracks the value of that asset, and then you have a version of that contract that exists on the Ethereum blockchain. Now, this contract that exists on the Ethereum blockchain can hold tokens. It can actually also accept Ether. So from the point of view of an investor can send Ether, the cryptocurrency, into a smart contract and in return get allocated tokens that have been created by that smart contract associated with their Ethereum address. And these smart contracts, depending on the ambitions of the developer, you can deploy something there and you can do it in such a way that it's actually impossible for you to modify it once it's gone out there. There were some people back at early last year who did something called the DAO. The idea was that it was a smart contract that would just live on the Ethereum blockchain. People could buy into it, they could get tokens out, and over time it just became like an investment vehicle, but no one actually owned it. It was completely decentralized and autonomous. However, as is always the case with code, someone found a bug and they were able to withdraw about $60 million US dollars worth of value from that. So it's, one of the people obviously learned from it, but I think it's an example of just how powerful this technology is, but also how much it's still very much so in its infancy as well. So with those sorts of contracts, if you want to see like a reference example of a smart contract that can do tokenization and so on for you, there's actually an Ethereum token standard that's been developed, and I've got an implementation of it using these smart contract wrappers in the Web3j, so you can have a dig around the docs and so on, and you can see it there. And there are lots of other smart contract examples within the code, but again, there's lots of information online about this stuff, and there's you can figure it all out for yourselves. So in summary, I recommend if you're going to work with Ethereum and you want to do stuff from Java, you take a look at Web3j. The reason being is that there'll be an awful lot of stuff that you need to re-implement if you want to do it yourself. I've spent a lot of time working on the documentation for the library as well, because as is often the case with a lot of emerging technologies and just over time working with different libraries and so on over time, I've seen how frustrating it is when you've got a library with bad documentation or incomplete documentation and so on. So I tried to tie together a lot of information from the Ethereum ecosystem into one place as well, so you don't find yourself having to go to lots of different areas in order to figure it all out. There's also integration tests as well for things like sending Ether, releasing and interacting with smart contracts and so on too. So there's plenty of example code there too to sort of get you up and running. So for further information, start just with the project's page on GitHub and also the documentation there. There's a chat channel on Gitter too, where you can jump on there if you've got any questions or anything like that, and also on my blog as well, where I'll be talking about new things happening. The other thing is, if you do want to get up and running and have a play around, I'm more than happy to send you Ether from my testnet account anyway, just to get you working with all of this stuff quickly if you can't be bothered to mine it, but it's not that difficult. That's all I was going to say today. Has anyone got any questions?